So there was a minor error in the solution, which was pointed out by Manmohan. So before we go into the solution, I would like to say two things here. First, first of all, Manmohan, very sincere apologies that I made such a silly mistake here. The mistake was that I didn't complete the solution. I stopped at calculating the acceleration instead of finding the coefficient of friction as well. Apologies for that. Second of all, I really appreciate you because, in fact, I'm so thankful to you that you spared your time to point out this mistake and to mention that in the comments. You know, you could have usually very easily skipped that, but instead you chose to mention that in the comment box. Without which, to be very frank, I wouldn't have realized this mistake. So thank you again. Okay, having said that, let's now move on to the solution. So just to have a quick recap. So we had a bullet of mass 0.1 kilogram embedding into a wooden block of 3.9 kilogram, and then the system moving under the force of friction alone. We've been asked to find out the coefficient of friction. So what was the complete system about? So before impact, bullet and block. After impact, bullet and block were together. So this much was the region where we applied law of conservation of linear momentum. And from the initial to final condition, this is where we apply equations of motion, right? When we use law of conservation of linear momentum, we got that the velocity is equal to 10 meter per second, right? And then using equations of motion, we found out that acceleration is equal to minus 2.5 meter per second square. Now the block here is coming to rest due to friction. This is where the free body diagram comes in. I should have added that as well. So this is the block, M plus M. So the vertical forces acting here is weight, which is mass of the block plus mass of the bullet times acceleration due to gravity. And the vertical forces acting up is normal reaction. And the only force that is acting on this body opposing the motion is the force of friction. And the net direction of motion is towards the right. So any force towards the right would be taken as positive. Any force towards the left would be taken as negative. And from Newton's law of motion, we have sigma fx is equal to m into ax. What is sigma fx? Sigma fx is fr. Since being acting on opposing the motion, this becomes minus fr is equal to m into ax. Is we found out the value of acceleration to be minus 2.5. So this becomes minus 2.5. Now, what is fr? Fr is mu into n. What is n? Since this body is neither moving upwards nor moving downwards, the vertical forces can be equated, which means the normal reaction n can be equated as the weight of bullet and mass. Bullet and block, right? And therefore, mu into n can be replaced by mu into m plus m into g. Likewise, this m has to be m plus m. Why? Because we are talking about both the masses. Therefore, negative and negative here gets cancelled, and what we have is, my bad, there shouldn't be a negative here, this would be plus. Okay. So mu into m plus m into g is equal to m plus m into a. M plus m upon m plus m is 1. Mu g is equal to u. Therefore, mu is equal to a by g. Acceleration is 2.5, and therefore mu will be 2.5 by g, which is 0.25, which actually is the the final answer that we were supposed to find out. So once again, thank you, Manmohan, for pointing out the error. And now I think we have the correct answer as 0.25, which is which is option D, right? So so please go through solution one more time. If you find anything which requires further attention, please make sure that you please make sure you feel free to reach out to me. I'll be more than happy to assist you further. All right. Okay. So thank you, Manmohan, one more time. Good luck for your exam and for your future preparation as well.